Let's take some definite integrals. Definite means they have bounds. So first we're going to take the antiderivative. The antiderivative of e to the x is e to the x plus c, or in this case, e to the x, and then we use an evaluation bar from 0 to ln of 5. And so now we're going to plug in, fundamental theorem says plug in your upper bound first, minus plugging in your lower bound. Well, e to the ln of 5 is just 5. Minus e to the 0 is 1. So the net area under the curve of e to the x from 0 to ln of 5 is 4. We can do another quick one below there. Well, first I would say we should rewrite this because we have x in the denominator. So we're going to rewrite the integral from 1 to e to the 4th. And we're going to say this is x to the negative 1 dx. Now I'm ready to add 1 to the power, putting the bottom put up top. So negative 1 plus 1 is 0. So we'd have 1 divided by 0, x to the 0. That's the only one where adding 1 doesn't work because we get 0. Anytime you get 0, you're thinking ln of x plus c, or in this case, ln of x, and we're going to put an evaluation bar from 1 to e to the 4th. So we have ln, and e to the 4th is a positive number, so we don't have to write the absolute value anymore. Minus ln of 1 is a positive number, so we don't technically need the absolute value, though it's fine to have it. Ln of e to the 4th is 4, minus ln of 1 is 0. So 4 minus 0. This curve of 1 over x on the interval from 1 to e to the 4th, we don't even have to draw boxes and do a Riemann sum. The perfect net area is 4 for that. We can do one more quick one down here. Again, I would rewrite to start. So I'd have the integral from 1 to 100. And we really have x to the negative because it's in the denominator, and 1/2 because it's under a square root. So I'm going to have to add 1 to that power. I'm going to do some side work up here, or right below there, wherever you want to put it. We'd have negative 1/2 plus 1 is going to be plus 2/2, which will give us 1/2. So we add 1, divide by it, and raise it as our new power. So we'd have 1 over 1/2 x to the 1/2, which means we have to flip that. 1 divided by 1 over 2 is going to flip to be 2 over 1 x to the 1/2 when we take that antiderivative. So again, negative 1/2 plus 1 ends up being x to the 1/2, and flipping that fraction out front gives us 2x to the 1/2, and we're going to plug in from 1 to 100. I remember that 1/2 is the square root though, and I have a square root button on my calculator, so I'm probably going to use that button on my calculator instead of writing 1/2 on there. So I'm going to do 2, and then x to the 1/2 is really the square root, so I'm going to do the square root of 100 minus 2 times the square root of 1, which is going to give me 2 times 10, which is 20, minus 2 times the square root of 1 is 1. So I have 20 minus 2. This answer, the net area under the curve, 1 over the square root of x on the interval from 1 to 100 has a net area of 18.